All right, part 2 from what we did yesterday, right? We talked about simplifying radicals. This is our radicand, what's with the radical, and then the index is the number, the root that you're taking. In this case, we're taking the square root. That's all we have to look at. So today, we talked yesterday about adding and subtracting. When you add and subtract radicals, the last name has to be what? The same, right? Square root of 5 plus square root of 5, whatever. We can do things to make them the same. We can simplify and all that. But now we're going to talk about multiplying, and then we're going to talk about dividing. This isn't bad, I promise. If I have a radical out in front of a parenthesis, what are they asking you to do? Distribute, okay? So we can look at this and say, a radical times the exact same radical. What happens to the radical? It disappears. If you guys don't remember that, no big deal. What's the square root of 5 times the square root of 5? The square root of 25. And then I have minus. Can you multiply something that's outside of a radical with something that's inside of a radical? No, it's like saying 2 times x. What would you do? You just stick them together? Same thing here. So you're going to say minus 2 square root of 5. And then you say, can I simplify? What is the square root of 25? 5. So this is just 5 minus 2 square root of 5. Can I simplify that anymore? No. No. Do they have the same radical last name? They do? They both have a square root of 5 at the end? That's like saying 5 minus 2x. You guys would say, oh, no, you can't do anything else. Same thing. You can't do anything unless the radicals at the behind it are exactly the same. All right, this is an important one. We're going to talk about what this means here in a second. But what do you guys notice about number 14? It's the same, right? Same terms, right? But the signs in the middle are different. So let's go ahead and FOIL this. You guys remember how to FOIL when you have two binomials? First times first. So first times first, what's 4 times 4? 16. Then I say the outer one. So the first times the outer one. I have a 4 on the outside, a negative root 11 on the inside, so we just stick it together. Minus 4 square root of 11. Now we're going to do the inside ones. It's a positive 4 with a square root of 11 attached. And then what happens when I multiply the same radical by itself? What happens to the radical? It disappears. So I have a positive and a negative one, so it's going to be minus the square root of 121, which is going to be 11. I'm just going to write it for right now. And now we're going to simplify. What happens right here in the middle, guys, when I have negative 4 root 11 and positive 4 root 11? They cancel out. They're gone. And then what is the square root of 121? 11. So this just becomes the whole number 11. So what are you left with? 16 minus 11, which is 5. Perfect. So when you multiplied those two together, what happened to all the radicals? They disappeared, right? They canceled out. When you have two parentheses that are like the same, but the signs are different, these are called conjugates. We're going to need that in a second. Conjugates. It just means opposite. Because you're not allowed to have radicals in denominators ever. So what we're going to have to do is multiply by the conjugate to get the radical to go away. We're going to practice that a little bit. Hopefully we remember foiling, because we're going to be doing that a lot. All right, let's look at the next one. All right, understand, guys, that 2 on the outside we don't do this. You do not do that. You cannot distribute an exponent over a plus or a minus sign. When we have our parentheses and then just all the letters and numbers together, you can distribute to everything. But if you have a plus or a minus sign, you cannot do that. What this means is I have the parenthesis 3 squared is 7 minus 5. How many times? Twice. If I told you 5 squared, you tell me I have 5 how many times? Twice. So what that's telling you is you have that one. And then a negative root 5 and a negative root 5 is going to give me positive, because a negative times a negative is a positive, and I have the square root of 25. Sure. All right, we're going to FOIL. We're going to go outside, the outside term times the outside term. So the numbers on the outside of the radical, 3 times 3 is 9. And then the inside, so the square root of 7 times the square root of 7 gives me the square root of 49. Now I'm going to take this term and go to this one back here. So notice this is underneath the radical. So the 3 is going to stay on the outside. It's negative because there's a negative sign right there. And then what's inside the radical, the 7 and the 5, we're going to multiply together to get 35. Then I'm going to say negative 5 times 3 square root of 7. So what's on the outside? Oh, shoot, that's not negative 5. There's a radical, I erased. So then I have minus, there's a 3 on the outside, right? So minus 3. And then on the inside, 5 times 7 is 35. And then I have this one times this one. So it's a negative times a negative is a positive. And square root of 5 times square root of 5 is going to give you the square root of 25. And then now we have to simplify. So I have a 9 out here. What is, guys, the square root of 49? 7. So cross this out. We're going to multiply 7 right there. I have negative 3 root 35 and another negative 3. So we're going to combine those. What does that give me? Negative 3 and negative 3 is negative 6. Good. So minus 6 square root of 35. And then I have plus, what is the square root of 25? 5. So right here, what's 9 times 7? 63. All right, so 63 plus 5. Can we add those two numbers together? Yes or no? Yeah, they're both just whole numbers. So 63 plus 5 gives me 68. And then you have your minus 6 square root of 35. How come I cannot simplify that anymore? Why can't I combine those two things? Because the 6 has a square root of 35 attached to it. The 68 does not. They're not like terms. It's like saying 68 minus 6x. You guys would say, oh, no, I can't do that. It's the same exact thing. The radical, just treat it like it's a variable. Yeah.
Why would the 3 square root of 35 times 5?
Because you're just adding them. You're not multiplying them. There's negative 3 there and negative 3 there, so our total of negative 6. Sure, of course. You don't have to ask. All right, let's look at the next one. This can get confusing. I understand that. We're distributing this out here, right? Remember, guys, tell yourself outside times outside, inside times inside. So when I multiply here, what are the two numbers that are on the outside? The 3 and the 4, right? What is 3 times 4? 12. Now we're going to multiply the inside times the inside. What is 6 times 6? 36, all right? Now I'm going to take this and I'm going to multiply it here. Where is the 3? Is it inside a radical or is it on the outside? It's on the inside. So what are you going to multiply that with? The 3 or the 6? Perfect. So I have 3 square root of, what's 6 times 3? Perfect. Good job. And now we just have to simplify a little bit. Do you guys know the square root of 36? Perfect. So I'm going to cross that off, and I'm going to make this a 6. What do I do with these two numbers on the outside? Perfect. 72 plus 3. What can I break 18 into? Look at you. 9 and 2. Why did Nate pick 9 and 2? Because 9 is a perfect square. So when I take out that perfect square, I have 72 plus what? 9 square root of 2. Very good. Can I add those two together? No. Some of you are looking at the screen like this. That's okay, right? We're going to practice this. You guys are going to have practice tonight on it. We're going to practice it tomorrow. But if you just stare at it, if you just copy from somebody else, you're not going to be able to do this on your quiz. You need to ask for help. I am here to help. You have friends in here that know how to do it. They can help you as well. All right. Here's where this gets a little bit tricky, so I want you guys to pay attention. Don't give up on me, Nick. Don't give up. All right, does anybody know what the problem is with this problem right here? Why is that not simplified? Why is that not okay? There's a radical in the bottom. All right, you're not allowed to have a radical in the denominator, ever. So what you guys were taught in Algebra 1, and if you don't remember it, we're going to relearn it. How do we get rid of this radical? We're going to multiply. It's called rationalizing. You're going to rationalize. You're going to multiply the top and the bottom by the square root. And the reason why is this. I'll show you. What happens when you multiply the square root of 5 times the square root of 5? You get the square root of what? 25, which is 5. It makes the radical go away. All right. Now, every time you see a radical in the denominator, when it's just by itself, you can rationalize. You can just multiply the top and the bottom. But sometimes when you do that, because if we were to continue this problem, you'd be left with the square root of 50 over 5. Can we break down 50? Yep. What times what gives me 50? A perfect square and a non-perfect square. 25 and 2. Perfect. And then what is the square root of 25? So this comes out. And then what can I do with the 5 on the top and the 5 on the bottom? We can divide. So I'm left with just the square root of 2. God bless you. God bless you. Say it again. Mm-hmm. A number that when you take the square root of it, like if I multiply 5 times 5, I get 25. So 25 is a perfect square because you multiply 5 by itself 2 times. So your perfect squares would be like 9, 3 times 3. 16 is 4 times 4. 25 is 5 times 5. 6 times 6 is 36. So 36 is the perfect square. What you guys can do to make your life a little easier. What do you notice about what I wrote here? The square root of 10 over the square root of 2. What do you guys notice about both of those numbers? They're not perfect squares. Good. How are they both written? What about here? What if I say, can I simplify that? What number goes into both 15 and 10? 5, right? Okay. Same thing goes if you have two numbers that are written underneath radicals. They're both written underneath radicals, correct? So if you have two numbers that are written underneath radicals, you can simplify first. What number goes into both 10 and 2? Okay, so if I divide this by 2, it goes away. It's just 1. And if I divide this by 2, it becomes the square root of 5. So the same thing could be said for here. When you start off this problem, and this just helps making your simplifying easier, the first thing you should do when you have a radical over a radical is see if they simplify. Does this simplify? Yes or no? Yeah. How does it simplify? Okay, this goes away and this becomes a square root of 5. And then there's your answer. It's just that. That's all you have to do. The problem lies here. Because what is the problem right there? There's a radical where? In the denominator. So what did we do before? We said, oh, we'll just multiply the top and bottom by the square root of 5. We get 2 square root of 5 over 5, and we're done. That's not going to happen here because if you multiply the bottom and the top by the square root of 5, the radicals aren't going to cancel out. So what did we do on the last slide when we had a binomial, two terms, a number and a square root? What did we multiply by? I wrote the word. We worked it out. What did I multiply by to make the radical cancel out? The conjugate. Conjugate means opposite. What is the opposite of 2 plus the square root of 5? 2 minus the square root of 5. And what you do, guys, in a fraction, what you do to the denominator, you have to do where? To the numerator. You always have to be fair. What you do to the denominator, you do to the numerator. So again, let's reiterate. What is our issue? There's a radical where? In the denominator. So let's FOIL the denominator and see if it fixes our problem. What is 2 times 2? 4. I have 2 times negative radical 5. So it's minus 2 times the square root of 5. Then I have positive 2 times the square root of 5. So plus 2 square root of 5. And then I have positive root 5 times negative root 5. What's 5 times 5? Okay, so I have minus the square root of 25. What do you guys see happens right here? With a negative 2 root 5 and a positive 2 root 5. They cancel out. Good. And then can I simplify this? What is the square root of 25? So this goes away. So what am I left with on the bottom? 4 minus 5. Did the radical cancel out? Yes. Is that what we needed to happen? Yes. So we know we did the right thing. And now we just multiply the top. What is 1 times 2 minus square root of 5? 2 minus the square root of 5. If you guys can remember to just take whatever's in the denominator and change the sign in the middle, it'll work every time. Now again, we have to practice this. You guys cannot watch me do 2 of them and then just be like, okay, I'm done. I'll be good for Friday. Quiz number 1, we can't just be like, okay, I don't know how to do this. We're going to get through Algebra 2. We're going to do it together. This is how I want you to work on these problems, right? First things first. What is the problem in number 17? Radical in what? The denominator. You could, don't do this, you could say, okay, I'm going to multiply the top and the bottom by the square root of 35. Is that the smartest idea? No. Should we spend our whole time just multiplying numbers together? No. What do you notice right here, guys? With the 7 and the 35. Are they both underneath a radical? Yes. Does 7 go into 35? Yes. So simplify that. 7 goes into 7 once, so that leaves you with 6, times the square root of 1, which is 1, over, how many times does 7 go into 35? 5 times. Now your problem is much easier. It's easier to work with. We still have a radical in the denominator. How do we get rid of it? We're going to do something called rationalizing. We're going to multiply the top and the bottom by what? The square root of 5. Good. And we're doing that because we've got to get the radical to go away. So when I have something on the outside and something on the inside, how do I write it? 6 times x, how would I write it? 6x. So if I have 6 times the square root of 5, I have something on the outside of a radical and something on the inside. How do I write it? You just stick it together. 6 times the square root of 5. And now on the bottom, what is the square root of 5 times the square root of 5? The square root of 25, which is just 5. So your answer here is 6 square root of 5 over 5. Can I cross out the 5s? Correct. How come?
Because they're not both under radical.
Correct. If they were both underneath the radical, you could. But the square root of 5 is not the same number as the whole number 5, so there's your answer. All right, let's look at 18. What's the problem with 18? The 3. Very good. It's underneath the radical. So the first thing I'm going to do is say, is the radical on the top, will it simplify with the radical on the bottom? It doesn't. Okay. All right, no problem. So how do I get rid of that radical 3? We're going to multiply the top and bottom by the radical 3. So in the numerator, guys, outside times outside, inside times inside. What's 7 times 1? 7. What's the square root of 2 times the square root of 3? Perfect. Square root of 6. And then I'm going to multiply here. The square root of 3 times the square root of 3 is square root of 9. What is the square root of 9? There's your answer. Always try to simplify underneath the radicals first, then rationalize. Multiply top and bottom by the radical on the bottom, and then just simplify. All right, and then we get to a problem like this. You're definitely going to have one of these on your quiz, so make sure you're paying attention. What is the problem? Radical in the denominator, but this one has something attached to it, so I can't just say, oh, I'm going to multiply by square root of 2. I have to multiply by the what? Conjugate, the opposite. What's the opposite of 3 plus the square root of 2? Perfect. What you do to the bottom, you do. Wonderful. I like to work the denominator out first just to make sure everything cancels like it should. So we're going to say first times first. What's 3 times 3? 9. What is 3 times negative square root of 2? Minus 3 square root of 2. Just stick it together. Now I have the square root of 2 times positive 3, so plus 3 square root of 2. And then I have the square root of 2 times negative square root of 2. It's going to be a negative, what's 2 times 2? Okay, so square root of 4. What happens here in the middle? They cancel. Isn't that what we wanted to happen? And then what is the square root of 4? 2. So my denominator is 9 minus 2, which is perfect. That's exactly what we needed to happen. Now in the numerator, I'm going to multiply 1 times this. What do I get? 3 minus the square root of 2. And there's your answer. You guys try the last one. All right, let's try to work it out. What am I multiplying the bottom by? 1 plus the square root of 2. Guys, you got to be fair. What you do to the bottom, you do where? To the top. So 1 plus the square root of 2. Let's worry about the denominator first. Make sure everything cancels like it should. So I'm going to FOIL outside times outside. 1 times 1 is 1. 1 times positive root 2. Which just gives me plus the square root of 2. Negative square root of 2 times 1 is negative square root of 2. And then a negative times a positive is going to give me a negative. What's the square root of 2 times the square root of 2? It's the square root of 4. Anybody have any questions about what I just did? Yeah.
Why is it negative 4?
Because a negative times a positive is going to give you a negative. So now, guys, what happens right here in the middle with negative root 2 and positive root 2? They cancel. Great. And then what is the square root of 4? It's the whole number 2. So what are you left with on the bottom? 1 minus 2, which is negative 1. So did what we need happen? Yes, sir.
What would you cross out?
The square root of 4.
No, like
The negative root 2 and the positive root 2 in the middle. They cancel. So now we said, okay, good. Everything canceled like it should, so we can go back up to the top. So let's FOIL the top. What is 3 times 1? 3. What is 3 times the square root of 2? Perfect. You just stick it together. 3 square root of 2. What is the square root of 2 times 1? Plus, I'm going to write a 1 square root of 2. And then the square root of 2 times the square root of 2 is plus the square root of 4. So now, guys, what is the square root of 4? 2. So what can you add on top? The 3 plus 2, which gives you 5. Good. And then I have 3 square roots of 2, and I'm going to add 1 more to it. So that gives me plus 4 square root of 2. Can I add those two together? No, I can't because they don't both have a square root of 2. You can leave your answer just like that. Some of you are going to say, what do I do with the negative? If you wanted to write it as negative 5 minus 4 square root of 2 and not have a denominator, you can. But you're perfectly fine with just leaving it just like that. Yeah?
Why wouldn't we be able to just cancel the radical 2's in the beginning?
Where?
Like in the starting problem.
At the top? Oh, you mean, oh, okay, good question. So like you have 3 plus the square root of 2 over, was it 1 minus? All right, question is, how come I just can't do that? All right, that's a very common mistake. The reason you can't is because the 3 is stuck together with the square root of 2, and the 1 on the bottom is stuck together with the negative. So it's not like if it was just radical 2 over radical 2, then yes, that does equal 1. But you have to look at this like it's one whole thing. So in order for you to cancel that out, it would have to be the exact same on the bottom. Good question. Anytime you have something with a plus or minus sign, just put a parenthesis around it to kind of remind you of that. All right, so you guys have practice problems that you can work on. All right, it's in your best interest to work on them, to practice them. Ask me if you get lost or whatever. You also have the quiz review up. I am not collecting the quiz review. If there's a couple questions you want to look at and just do some of them, if you want to do them all, whatever. I'm going to do every single problem tomorrow, and I'll record it, and I'll post the answers so you guys have something to look back on to study.